few important questions are left over here. Let's take that. So let me write the question at first. Okay, so the question we are having, that is, two circles intersect at 2 points. Can you see my screen? Can you see my screen? Okay. So two circles are there which intersect at 2 point B and C. Through B, two line segments ABD and PBQ are drawn to intersect the circle at A, D and P. A, D, P, and P, Q, Two circle intersect at 2 point B and C. Through B, two line segment ABD, PBQ are drawn to intersect circle at A, D and PQ. Okay, respectively. Proof that angle ACP is equals to angle QCD. Figure also it's given over here. We are having a circle like this. Okay, two circles are there. So we are having a circle like this. One more circle is there. And there is a line AC. Then AD. Here we are having CQ. Here QP. Then P2. Like this. And this one is also joined. Okay. So I'm not drawing the figure by myself. Okay. The figure is already given in the question. And the question, it is mentioned that two circles intersect at 2 points. Here you can see two circles intersect at 2 point B and C. Through B, two line segment ABD. Here you can see. Where is B? Just a moment. This is B. So through B, two line segment ABD, as you can see, and PBC are drawn to intersect the circle at A, D and PQ. As you can see, A, D, P and Q respectively. Prove that angle ACP is equals to angle QCD. That's what we have to prove over here. Angle ACP, this one, let me mark it. Angle ACP, this angle is equals to angle QCD. QCD, this angle. This two we have to prove that these two angles are of same measurement. So any idea what can be done over here? This is the figure we are having, a very random figure as you can see over here. And this two green angle which we are having over here, this two green angle we have to show these two are equal. Do we have any other information? No, we don't. Can you see? Just a line segment and everything is mentioned. This is intersecting that. That is also mentioned in the figure itself. So we just have to focus on the figure and we have to prove this one, the rectangular box one. What to do? Any idea what to do over here? See what can be done. So if let's do one construction by ourselves. So we can join A with B. We can join this D with Q. Okay, construction we are doing by ourselves. That is joining A and P as well as Q and T. Okay, we are joining it. Now, since we have made this purple line, let's focus on A and P. So can we say this one and this one both are in the same segment of the circle? Can I say that if I am having a circle and if there is a point A, there is a point P, then here we are having one angle and here we are having one angle and both will be equal. Here this angle at C and this angle at B both will be equal to each other. Why? Why? Because angle in the same segment are of same measurement. Yes or no? Can we say angle in the same segment are having same measurement? You can see these two angles are in the same segment of the circle. Okay, so we can say that angle PBA is equals to angle ACP. Why? Angle in same segment are of same measurement. You need to write the complete like the theorem. Similarly, if we will focus on this QD, the green one here, can we say that this angle and this angle, I'm talking about this angle, this glittery one and this glittery angle, these two will be same. Why? Again, angle in the same segment of the circle are having same measurement. If you wanna check, you can check. We are having a circle like this, there is a chord like this, okay, or the segment, the major segment, minor segment. Now we are getting one angle over here and another angle over here. I'm talking about this angle and this angle. Angle in the same segment are of same measurement. Okay, let's take that. So this is equation number 1. Okay, I am writing that angle QBD is equals to angle, just a second. So we have written QBD is equals to DCQ. Okay. Again, the same theorem we are using. Angle in same segment are having same measurement. Okay. Now, if we will compare, before comparing these two equation, we can notice one more thing over here. Lines and angles chapter you have already completed. So can we say that if this line and this line are intersecting each other, then this angle and this angle are vertically opposite angle? Yes or no? Two lines are intersecting each other and this are vertically opposite angle. Can we say?
Yes, ma'am.
Let's write it. So I am going to write angle PBA is equals to angle QBD. Okay. Angle PBA is equals to angle QBD. Why? Vertically opposite. So we got three equations. Now let's combine all the three equations. So here we are having PBA, here we are having PBA, here we are having QBD, here we are having QBD. So at the place of PBA, I am going to write ACP, angle ACP. And at the place of QBD, I am going to write DCQ from 1 and 2. We have from 1 and 2, we have taken a angle PBA and we have substituted it in equation number 3. From equation number 2, we have taken QBD and we have substituted it in equation number 3. So for 1 and 2, whatever information we are having, that we have substituted in equation number 3. Okay, now let's see what we have to prove. We have to prove that ACP QCD. Can you see ACP QCD? This and QCD is the same thing. Okay, if you are not sure, angle DCQ and angle QCD is the same angle. Okay, is it okay? So we are done
Yes,
with the
ma'am.
piece. Can you see? Let me summarize the whole thing. This figure was given. Okay, and if we will start thinking that what to do over here, very complicated figure is there, so many line segments and so lots of point of intersection and everything is there. But here the approach is very simple. We will join P and A, we will join Q and D, and after just joining P and A, you will be able to observe that you are getting two angles which are in the same segment of the first circle. Both the angle will be equal. Similarly, after joining Q and D, you will realize that there also you are getting two angles which are in the same segment and the hence will be equal. Okay, we are also getting one pair of vertically opposite angle. Now we are just taking all the three equation and we ended up getting the proof. That's it. Okay.
Okay.
Is there
Okay,
any
ma'am.
confusion in this one? Let me know. Is there any confusion?
No, ma'am.
Okay, just give me a moment. Let me have some water. Okay, so this one is clear. Let's take another question. If the next question, or you can say the theorem, is if the non-parallel sides of a trapezium are equal, prove that it's cyclic. Now, previous day only we were discussing about cyclic quadrilateral, and we have discussed that in a cyclic quadrilateral we are having such a quadrilateral where all the four vertices of the quadrilateral are lying on the circle. That's called cyclic quadrilateral. And we have taken the cyclic quadrilateral. There one theorem was there that the sum of opposite angle of the cyclic quadrilateral will always be 180 degree. So if we are having any quadrilateral where the sum of opposite angle is 180 degree, where the sum of this angle 1 and angle 2 is 180 degree, then we can say it's a cyclic. Okay, if we are having such a quadrilateral where the sum of opposite angle is 180 degree, then we can say it's cyclic. Okay, अगर हमारे पास कोई भी ऐसा क्वाड्रिलेटरल है जिसका अपोजिट एंगल का सम 180 डिग्री आ जाता है, देन वी कैन से इट्स cyclic. Why again and again I am repeating the same thing? Because here we have to prove that we are having a trapezium and that's a cyclic. So we just need to prove that the sum of opposite angle is 180 degree. If that we can do, then we will be able to say that yes, it's a cyclic. Okay, let's move ahead. So it's talking about the trapezium. If the non-parallel side of a trapezium are equal, if the non-parallel side of a trapezium are equal, we are having a trapezium. Here we know that this side and this side are parallel with each other. This side and this sides are parallel with each other, known as bases of the trapezium. Base. Okay, and this one are the non-parallel side known as legs of the trapezium. That much we know about the trapezium. Now what the theorem says, if the non-parallel side of trapezium are equal, that means a b c d, ad and bc, these two are non-parallel side. These two are non-parallel side, and also it's given over here in the theorem that the non-parallel side are equal. That means AD is equals to BC. That is given in the theorem itself. Now what we have to do? We have to prove that it's a cyclic. Cyclic means opposite angle sum. If we will be able to take out as a 180, if we will be able to show as a 180, then we can say it's cyclic. Okay, let's see what can be done over here. So for here also we'll be doing one construction. What we can do, we can drop a perpendicular from A over here. A perpendicular I'm dropping over here. And we can drop a perpendicular from B over here. A perpendicular I'm dropping, and I'm saying, let's say this is M, this is N. Okay, so we have dropped two perpendicular, one from A, one from B on the side CD. Okay, now we will be taking two triangles. As you can see, one triangle on the left side, another triangle on the right side. So you can take two triangles over here. I'm talking about triangle ADM and triangle BCN, and we will try to prove that these two triangles are congruent triangle. Okay, let's see what can be taken over here. So we can say that here we are having 90 degree and there also we are having 90 degrees. So yes, that we can take. So we can take that angle AMD over here is equals to angle B and C over there. That both are 90 degree according to our construction. Okay. Now what else? So we can say that here it was given that AD and BC are same. So we can say here side AD is there on the left triangle, and on the right triangle BC is there. That was already given that non-parallel side are equal. Non-parallel side are equal, having equal length. That is already given in the question. Okay. Now what else can be taken over here? Any idea? Can you see both the triangle, the left one and the right one? Please let me know what else can be taken over here. What else we can take?
A AM and BN is common.
AM and BN both are same. Why?
Yes. Because both are 90 degrees.
Due to 90-degree it's same. Yes, everyone agreeing with her. Yes, A and BN are same, but why it's same? Is it so that since we are making, we have dropped a perpendicular, that's why it's same? Here we can use the concept that if we are having two parallel line, the distance between parallel line will always be same, always. Okay? Anywhere you draw the distance, you take the distance. If we are talking about two parallel line, then the distance will always be same. It will not, somewhere it will be smaller, somewhere it will be more. It will not be like that. Okay? So that's why the distance between the parallel line AB and CD are same. Distance means perpendicular distance. Distance means perpendicular distance. So obviously distance between the parallel line AB and CD are same. Now if you will ask who said to us that these two are parallel line? Because it's a trapezium, and in a trapezium there must be a pair of parallel line. Okay. So in between these two parallel line, we know that yes, you said it correctly, that AM and Bn will be same, but the reason is distance between two parallel line are always same. Now from here we can write that triangle A, which congruency criteria is working over here, let me know. Triangle AMD is congruent with triangle BNC. Which congruency criteria is working over here? Anyone? Everything is written over here. You can check the figure and let me know which congruency criteria is working over here. Anyone from here?
Side angle, angles, side angle.
Angle side angle, let's check. We are using this angle. We are using this side and we are using this side. Side angle? No. Anyone from here? Are you able to identify? Everywhere we are talking about congruency, not only in triangle chapter, quadrilateral chapter, and here also. It's RHS. Can you see right angle, hypotenuse, and one of the side? Can you? So by RHS congruency, these two triangles are congruent with each other. Do we wanted to prove the congruency just? No. Okay. We have proved the congruency. Now from here we can say that angle AD, write it over here, that by RHS congruency criteria, these two are same. Now from here we can write that angle ADM is equals to angle BCN by CPCT. Okay, angle ADM, this angle and this angle are same by CPCT. Okay, let's give it a equation name. Now, if we are having AB and CD as a parallel line, AB and CD as a parallel line, and there is a line like this. So can we say the sum of this angle and this angle will be 180 degree? Can we? Can we say
Yes, ma'am.
it's co-interior angle, right? Or interior angle on the same side, right?
Yes.
So we can say since AB is parallel to CD and AC is the transversal, angle BAC is equals to angle not equals to plus or we can directly write in a trapezium. I am just writing straightforward. Angle A plus angle C is equals to 180. Why? Because AB is parallel to CD and it's a co-interior angle. So if A plus C is equals to 180 and previously what we have got? Angle D and C are same. Okay, here we have got by CPCT we have written D and C are same. Angle D is equals to angle C that we have written in equation number 1. And now we are saying A plus C is 180. So we can also say that A plus angle D is 180, right? Yes or no? From equation 1 and 2, can I write angle A plus angle D is equals to 180?
Yes, ma'am.
Let's get back to the figure. Wait. This has to be A plus D because I'm talking about I have given the wrong name over here. The below figure is not like the above one. Why? Because AB is okay, but CD I have given incorrectly. Okay. So here was C, here was D. We have got angle A plus angle D is 180 co-interior angle. Okay. And from 1 and 2, we are getting angle A plus angle C is equals to 180. Is it okay? From 1 and 2, we are getting angle A plus angle C is 180. Why we want to get angle A plus angle C only? You can check that we are having a trapezium and we have got here this angle A plus this angle C is 180. Can we say hence it's a cyclic? Can we?
Yes.
Just before starting this concept, I was repeating, no, that when we will say it's cyclic, when the opposite angle sum will be 180 degree. And successfully, we have shown that opposite angle sum is 180 degree. What we did, we are having a trapezium. We have dropped the perpendicular. We got two triangle, the left triangle, right triangle. We tried to prove both the triangle as a congruent triangle. Once we did so, we got that two angles are same. Which two angle? Two corner angle, two interior angle of this trapezium, adjacent interior angle became not same. Uh, it became same or what? Yeah, it became same. And then from the parallel line concept we got we got co-interior a pair of co-interior angle also. By taking this two equation we ended up getting the opposite angle sum is 180 degree and hence it's this quadrilateral, this trapezium is cyclic. Is it okay? Let me know, can we move
Yes.
ahead?
Yes, ma'am. Sure.
Okay, let me take another question. Now the next question is, yeah, this one. If diagonal of a cyclic quadrilateral are diameter of the circle through the vertices of the quadrilateral, prove that it's a rectangle. Let's do it. So here the theorem, in theorem it's mentioned that if diagonal of a cyclic quadrilateral, what's cyclic quadrilateral? We are having a circle. There is a quadrilateral like this. Okay. And if the diagonal of this cyclic quadrilateral are diameter of the circle, here is a center O and diagonal is passing through the center like this. And hence both are diameter. Okay. Through the vertices of the quadrilateral, prove that it's a rectangle. We have to prove that this A, B, C, D, it's a rectangle. Okay. So what can be done over here? Anyone? We are doing revision class. So please let me know whatever like you think that we can do for the particular question. We know the diagonal are the diameter. Okay. We know the diagonal AB, diagonal AC and diagonal BD both are the diameter and hence both will be equal. So if diagonal of cyclic quadrilateral are diameter of the circle through the vertices of the quadrilateral, prove that it's a rectangle. We have to show that this angle is 90, this angle is 90, this angle is 90, this angle is 90. That's what we have to prove at first. Just a second. Yeah. So let me show you one thing over here. If you will focus over here, this is the diameter. AC is the diameter. And here we are getting one angle. Angle ADC. Just focus on ADC. So can we say it will be of 90 degree? Why? There is a theorem also, and from where this theorem came, we know that whatever angle we are getting at the center, if there is a chord, okay, chord like this, or an arc like this. Let me take arc instead of chord. Chord. We are having an arc. This arc will make an angle at the center, and that angle will always be double of this angle, right? If this is x, this will be 2x, right? Angle subtended by an arc at the center will be double of the angle subtended by the same arc on the remaining part of the circle. Do you know this theorem? Are you familiar with this theorem? So by using this theorem, can we say that there is a chord, okay, or there is an arc? I'm talking about this arc, this arc, the totally half of the arc. I'm taking angle subtended by this arc at the center. So you can see this arc will subtend this angle at the center. That angle will be, you can say here, that angle will be 180 degree. And on the remaining part of the circle, if this arc will subtend any angle, so you can see the green arc is subtending this angle on the remaining part. That angle will be half of the angle which is there on the center. So this will be 90 degree automatically. Yes or no? Are you getting?
Yes, ma'am.
So this theorem only we are applying,
Yes, ma'am.
and we will say AC is an arc. Yeah, ABC is an arc. Or directly we will write, rather than giving that much elaborated explanation, if we will write that angle ADC is equals to 90 degree. Why? Because angle subtended by an arc at center is double the same theorem. Please write it completely. Double the angle, double the angle subtended by the same arc on the remaining part of the circle. Okay, theorem is clearly mentioned in your book as well. So the same statement as it is, we have to copy paste over here. We know that ADC is 90 degree. Now, if we will focus on this BD chord or BD diameter, this one BD, then can we say that this angle C will also be 90 degree? Yes or no? So we will say angle BCD will also be 90 degree. Again, angle subtended by an arc at the center will be double of the uh, angle subtended by the same arc on the remaining part of the circle. Okay. So this way, can you see interior angle we ended up getting as a 90 degree. 2 we have got 90 degree. Remaining, we can say remaining similarly angle B, angles A will also be 90 degree, and hence all the angle similarly angle B, angle A will also be 90 degree. That means we have proved that angle A, B, C, D all are 90 degree, but we have to show that it's a rectangle. So one more thing we need to prove, that opposite sides are of same length. Okay, a pair of, like, AB is equals to CD, AD is equals to BC. That's what we have to show. Any idea what can be done for that? It's a rectangle we have to show. It's a rectangle. What condition is there? Diagonal of a cyclic. This quadrilateral is cyclic quadrilateral. Think about it. What can be done over here? Anyone? Can we take this triangle? Let me take other color, otherwise it is just getting mixed up. Can we take this triangle also? And the blue one. And let's prove that these two are congruent. The blue one and the yellow one. Yellow one and the blue one. Let's prove that these two are congruent. Why? Then we will be able to say AD is equals to BC by CPCT. So I want to take triangle ADC and triangle BCT. Here, what are like what information we are having which will support that these two are congruent. So let's write. We know that angle D over here is 90 degree and angle C over there is 90 degree. So let's write it. Angle ADC is equals to angle BCD. Both are 90. Now only we have shown. Okay. Now what else? Both the diameter, both the chord, both the diagonal are the diameter. That means both the diagonal are of same length, right? We have written in the very beginning. We have written in the very beginning that AC is equals to BD. Okay, AC and BD are same. We have written it at first only. It was already given. What else can be taken over here? Anyone? Anyone? This type of figure we have proved in triangle chapter that these two triangle are congruent triangle. I am talking about the blue triangle and the yellow triangle. What can be taken over here? Can we say side CD is common in both the triangle? And therefore, triangle ADC is congruent with triangle BCD. Okay. And hence we can say, from here that side AD and side BC will be same by CPCT. And therefore, if opposite side AD and BC we have shown it's same, similarly we can say AB and DC will also be same and hence it's a rectangle, right? Similarly, AB and CD will also be same and hence it's a rectangle. What we have shown that each interior angle is 90 degree and we have also shown that opposite side of this quadrilateral is of same length and hence these are the property of rectangle only, right? Any confusion over here? Can we move ahead?
Ma'am, can you explain once again?
Yeah,
I didn't understand.
yeah. So first thing first, we are having a circle. There is a cyclic quadrilateral. What's the meaning of cyclic quadrilateral? Any quadrilateral where all the vertex of that quadrilateral are lying on the circle. So ABCD is a cyclic quadrilateral over here. Okay. We have to show that this quadrilateral is a rectangle. So what we have done? At first we have proved that each interior angle is of 90 degree. How we have done so? So we have done so by taking a circle and then diameter. This is the diameter we are having, A D. So we are saying that this diameter or this arc is making an angle at the center. An angle at the center, that angle is 180. So on the other part, on the remaining part, whatever angle it will make, that will be half of this angle. So that's why this will be 90 degree. From where I'm using this, like do we have any theorem like which will support our conclusion? So yes, exactly, we are having one theorem which says that angle subtended by an arc at the center is double the angle subtended by the same arc on the remaining part of the circle. Okay, so if you want to understand it, you can say that there is a arc AD and that arc is subtending angle at the center. So that angle at the center O, that angle at center O is 180 degree and hence angle AOD will be and hence angle, let me just give it a random name, APD, it will be 90 degree. Is it clear so far? So far,
Yes,
is
ma'am.
it clear?
Yes, ma'am.
Yes or no? We have
Yes,
discussed.
ma'am.
So, this is how we have got 90-degree over here. One more, just exactly like this, one more angle we have shown 90-degree by taking the other diameter. Okay, we are having one more diameter like this and like this, that is also making an angle. So, we are saying that will be also 90 degrees. So, this is how we have shown two angles are 90 degree. I am talking about angle D we have shown as a 90 degree by taking the blue triangle, or you can take the blue case, the blue one. And one more angle we have shown as a 90-degree by taking the yellow one. Okay, the BD as a diameter, and angle C we have shown as a 90-degree. After showing this two angle as a 90-degree, we are saying that angle A, angle B, angle C, angle D all will be 90-degree just like this. Okay, now we have to prove that this is a rectangle. Okay, so we have shown that each interior angle is of 90-degree. Now we also have to show that the opposite side of this quadrilateral are of same length. Okay, so what can be done for that? To show that opposite side of the this quadrilateral, we are having a random quadrilateral. You just understand, try to understand. We are having a random quadrilateral, and I am telling you, prove that it's a rectangle. So first thing first, you will prove that this side same, and this side same. Then and only then we can say it's a rectangle, no? And each interior angle also has to be 90-degree. Then only we can say it's a rectangle, right? So 90-degree we have proved. Now opposite side equal also we have to show. So what we have done over here, we have taken this blue triangle and this yellow triangle, and we have proved the congruency of both the triangle. How we have proved the congruency? 90-degree over there, 90-degree over here. We have taken that case. Now AC and BD both are the diagonal and both are the diameter. So both will be same. That also we have written over here. We have also taken that side CD are of same length. Okay. Side CD is common side in both the triangle. So hence both the triangle are congruent with each other. After proving the congruency, we are saying that, and hence since ADC, you can check here. We are saying that, let me show you. We are saying that ADC and BCD both are congruent triangle, and hence side AD and side BC will be of same length. You can get back to the figure. Let's get back to the figure. AD and BC are of same length. That means opposite side of this quadrilateral are of same length, right? And hence it's a rectangle. Can we say? Can we? Is it clear now?
Yes, ma'am.
Okay, let's move ahead. Okay, the last question from this chapter. I am taking question number 6. Please check it in your book. Here it says that A, B, C, D. I am dictating the question. Please listen to me carefully. A, B, C, D is a cyclic quadrilateral. A, B, C, D is a cyclic quadrilateral. I am not saying, it's written in the question. Okay. A, B, C, D is a cyclic quadrilateral whose diagonal intersect at a point E. Diagonal intersect at a point E. If angle DBC, this angle is 70-degree given in the question. And angle BAC, this angle is 30-degree This is also given in the question itself. Find BCD. BCD. We have to find this angle. Further, if AB equals to BC, find ECD. Okay, we will be taking this case. First, let's find BCD. So what can be done over here? Any idea? If we will take this chord, can we say this is making here angle and this is making their angle? So this 30° and angle over here will also be 30. Angle in the same segment are of same measurement, right? Yes or no? Now,
Yes,
after
ma'am.
taking angle in the same segment are of same measurement, if we will take triangle BDC, then can we find the unknown angle C? Getting it? Are
Yes,
you
ma'am.
getting? We are having, okay, this 30° is not known to us. Okay, that 30° is known. So can we say that this will also be 30? Because angle in the same segment are of same measurement. Just a second. Yes or no? Can we say this will also be 30? Because that is 30 and when we will take the segment this chord BC. Okay. Now from here we can take triangle BDC and we can find angle C by angle sum property. Okay. If this is 70, this is 30, angle C will be 80° by angle sum property of a triangle. We got angle C. Further, it is given that AB is equals to BC. Then find ECD. We are having a triangle where this side AB and side BC are of same length. Then we can say the opposite angle will also be same by isosceles triangle property. So this much C will be 30° only. If this is 30, other will also be 30. Okay. So we are saying that this is 30. Total we have found as a 80. So remaining will be 50. Okay. Angle ECD will be 50°. Is it clear?
Yes, ma'am.
Okay. So we are done with this circle chapter now. We have taken all the important questions from here. In like a very detailed discussion we have done for this chapter. All the important question, majorly all the question only we have taken over here. So please practice